To finish radicals, we have to talk about rationalizing the denominator. One of our rules was that we cannot leave a radical in the denominator. So the goal with rationalizing in the denominator is to eliminate the radical from the denominator. In order to do that, we want the exponent and the index to equal one another. So again, in order to rationalizing the denominator, we need to multiply by something so that our exponent and index equal one another. Alright, so let's take a look at a couple of examples. The first one, I think everybody knows how to solve. In order to get rid of the radical, everybody knows that we're going to multiply the top and bottom by radical 5. Remember, anything you do to the bottom, you have to do to the top. So when I multiply the top, 1 times radical 5 gives us radical 5 over, now we'll get the square root of 25, so the radical is going to cancel out and we're just left with 5. For the second example, it's a little bit more difficult. What I was mentioning earlier is that we want our exponent and index to equal one another. So in this case, my index is 3. In order to get rid of the radical, I need my exponent to equal 3. In this case, I have 7 to the first power. Well, how many more 7s do you need to have 3? Well, you need 2 more. So that means you're going to multiply the top and bottom by the cube root of 7 squared, since I needed 2 more 7s. So if I multiply the top, that 2 is just going to stay outside the radical. 7 squared is going to be 49 over. Now I'm going to write this step out, but you don't have to do it. If I multiply them, since they have the same base, since they both have base 7, when I multiply, you're just going to add this exponent, so you get 7 cubed. Notice now my index and exponent are equal to one another, so the radical cancels out. So that leaves us with our final answer, which is 2 times the cube root of 49 over 7. So that's our final answer. Alright, if you notice in the first couple of examples, the radicand, which remembers the number underneath the radical, happened to be a prime number. But in this case, we have 9. 9 is not a prime number. So you want to think, is there any way I can rewrite 9 in exponential form? In this case, 9 is the same as 3 squared. So that's my first step. I'm going to rewrite it in exponential form. Now remember, in order to rationalize the denominator, you want your index and exponent to equal one another, so that way the radical cancels out. In this case, I have 2 3's. So how many more 3's do I need to get 5? Well, I need 3 more 3's. So I'm going to multiply the top and bottom by the 5th root of 3 cubed. Now if I do that again, I multiply the top, that 5 is going to stay on the outside. 3 cubed is 27 over, we'll get the 5th root of 3 to the 5th, because you add those exponents. So then our final answer will be 5 times the 5th root of 27 over 3. Because remember, my index and exponent were equal, so the radical cancels out, and that's our final answer. Alright, let's take a look at the last example for this set. Again, notice my radicand is not a prime number, so let's think. How can we rewrite 8? Well, 8 is the same thing as 2 cubed. So I rewrite it as 2 cubed. So in this case, I need 7 2's. I already have 3, so I need 4 more 2's. So I'm going to multiply the top and bottom by the 7th root of 2 to the 4th. Now when I do that, I'm going to get 4x 7th root of 2 to the 4th, which is going to be 16 over 2. Notice in this case, you can cancel out a 2. So my final answer is 2x 7th root of 16. All right, let's start talking about when a radical is being added or subtracted with another integer. We talked about this last semester, but if a radical is being added or subtracted with another integer, then you need to multiply by the conjugate. And remember, the conjugate is simply the opposite sign. So let's look at the first example. I have 4 over the square root of 3 minus 8. So the opposite of the denominator is the square root of 3 plus 8. So that's what I'm going to multiply by on the top and bottom. So on the top, I'm just going to have 4 parentheses square root of 3 plus 8. On the bottom, technically you're supposed to FOIL these two, but we know since they're conjugates, the middle term's going to cancel. So you can multiply your first two terms together to get 3. Multiply your last two terms together to get minus 64. So in this case, our answer is 4 times the square root of 3 plus 8 over negative 61. And that's our final answer. All right, similar to the last one, again, we have a 3 plus square root of 2 in the denominator, so we need to get rid of this square root of 2. So we need to multiply by the conjugate, which is going to be 3 minus square root of 2. So 3 minus square root of 2. So if we do that on top, you're going to be left with 5 parentheses 3 minus square root of 2. On the bottom, remember, my middle term is going to cancel. Oops, sorry about that. My middle term is going to cancel, so you just multiply the first two terms together to give you 9. You multiply your last two terms together to give you minus 2. So if I go ahead and simplify that, you can't do anything to the top, and you're just going to have 7 on the bottom. So that's our final answer. So we've wrapped up radicals. The next unit or next section will be on factoring.